Azure is a multi-billion cloud platform, second in the global market share, right behind AWS. They have built services that scale to billions, petabytes, exabytes. I don't even know, right? And these services are extremely resilient, extremely scalable, extremely available, 5 nines of availability. They're just amazing. And the engineers that have built that, even they can make mistakes in API design. This video is mostly a case study or explanation of an issue I created in Azure SDK for Go, although it probably shouldn't have gone there. I created it here because it came from this library. But so it's a very nice example of how even the best of the best, I mean, I wouldn't call them the best of the best, but even extremely competent engineers can make bad API design choices. I'm specifically going to be talking about idempotence, but yeah, before starting, just a quick disclaimer, right? I'm not trying to dunk on Azure. It is a dunk, but that's not the intent. Also, uh, I'm not making this because I hate Microsoft. I mean, I do, but this is not the reason I'm making the video. And yeah, it's all fun and games. So what I'm going to be talking about specifically is Azure Blob Storage. What Azure Blob Storage is simply a, you can imagine a file system on a cloud platform, on cloud, where you can store files and get them, delete them, all that stuff, right? They are called blobs or objects or whatever they want to call it, right? And the equivalent on Amazon is S3, and on Google Cloud Platform it is called GCS. Yeah, Google Cloud Storage. So yeah, and we are going to be discussing about a very critical API. I mean, I wouldn't be dunking on this Azure API. I mean, I'm not dunking, as I already said. I wouldn't be blaming Azure if it was just any other API, but it is one of the most important ones, the one that is used for uploading the blobs. And you can already imagine if that is not idempotent, it's not a good news. But there's nuance to it. And I'm going to try to figure out what their thought process was, or is what I believe must have been. But we can never look into the brain of other people. So let's see. First of all, what is idempotence, right? So idempotence means that no matter how many times an operation is done, right, the result doesn't change beyond the initial application of that operation. So that makes an operation idempotent, right? That's called idempotence. Uh, so let's start simple, right? We're gonna try to explore and try to build towards this issue, like why does this arise and how they could have avoided it, and what's the general way guideline to avoid it. So let's take a get operation. Is that idempotent? What is a get operation? Get means get a particular blob, okay? A blob ID. That's what they call files in Azure Blob Storage, a blob. All right. So is get a idempotent operation? I mean, it depends on what you think of as the result. Is the file that you get the result, or is the speed at which you get the file combined with the file the result, right? Speed plus the data. I mean, latency plus data, or just the data. Obviously, this is not right. This is not what we generally mean by idempotent, but maybe in some particular scenarios we can mean it, but that's not the general uh, meaning when we talk about idempotent APIs. What we mean is the data, the result we're getting does not change. Well, what if somebody updates this file in parallel? Then the first operation will get us a file. Second operation will get us the same file if we call this operation multiple times, right? On third, let's say before we call it the third time, somebody updated their file. Now the data we have gotten is different. Does that make this API not idempotent? Well, no, not really, right? I mean, it doesn't fit the definition, but it does make sense. If it has been updated, then after update, no matter how many get calls you do, until it is updated again, it will give us the same result, the same data, right? So that's why it is idempotent. Okay. Now let's look at post. All right. So post to create a blob. Okay. So if you create a blob with, let's say, a particular data, this is the data, right? 010010. So if you give it a particular data and you do create blob multiple times with the same argument, the data and the name, will it give us the same result? I mean, first of all, what even is the result here, right? I mean, it's just a okay 200, right? So really what we're talking about is the state of the system. I mean, this is not the official definition, but it does matter. Basically, it couldn't be that one time you do create blob, right? Then it creates a blob, and then if you do it again, and it sees that, okay, so let's look at this. Look at it like this: you do create blob with a name and, all right, let's just say name and some data. If you call it first time, it creates that and it gives us 200, okay. And then you do it again, then it creates another file but with a suffix 1, and then it gives us 200, okay. Now the name, I mean the response is the same. Does that mean it is idempotent? Not really, right? It has resulted in a different thing to happen. When we talk about the result, we don't just mean the result that we get from the response. What we mean is what it affected in. We're talking about a logical concept on what was the result, what was the effect it did, really. Now here you can see creating a file with name changed the state in some way. Now creating it again changed it in another way. This should not happen, right? So what should ideally happen in an idempotent API is this, that they create with a name. So it created that file. Then if we do it again, it doesn't do anything. If the data was different, it will just update the data. But if the data was the same, name was the same, it doesn't really do anything. I mean, it may take a lot of time. It may overwrite it. It may rewrite it, whatever, right? It may delete it and write it again. But the final, state should be the same, more or less. So that's what makes the post API idempotent, the create block. And actually, their post API is idempotent. And the way they do that is, so first of all, I'm going to go over a quick nuance, the way upload operation works. It's very specific, not really relevant to the discussion, but I want to do it for completeness sake. So what you do is you upload chunks of data called blocks. Okay, so let's say you upload 32 MB large 10 chunks called blocks, and then you call a final API call called put block list. And this API call, so what you do is the blocks you have uploaded, right? So block 1, block 2, block 3, block 4, you give it their IDs in a sequence. And let's say you give let's say you have uploaded 4 blocks and you give the IDs like this: B1, B3, B4, B2. And then you say put block list. So it will create a blob that has contents like this: B1, then immediately after B3, B4, and then B2. And so it's a very small operation, the final commit operation, the put block list. Okay, now this is a idempotent operation because we don't know what it internally does. But if you write the same blocks, so if you've written, let's say, these 4 blocks, and then you do the put block list API call over and over again with the same sequence, it will result in the same file. And there is only that one file. That file is just being updated, and maybe they are not even updating it if it is not needed. Maybe they are updating it with a last modified time updated. So you might argue that, okay, last modified time has been updated, so it's not really a idempotent operation. But you have to define the scope of idempotence. You cannot make anything extremely idempotent or like 100% idempotent. That's just a weird concept. Like I was talking initially, right? Do you count latency in the result or do you not? That is technically, part of the result. Also, if you're talking about state of the system, what if on a get call, a cache is updated. Is that affecting our idempotence? We don't know, right? You have to define the idempotence. So here, the last modified time of that blob being updated is not really affecting our idempotence for whatever we are concerned. What we care about is that the blob exists and has that data, right? And yeah, that's what it does. Okay, and so that's how they keep it idempotent. But wait, then why am I saying that this is not idempotent? Well, that's where API design and business requirements and just with requirements, design needs to be updated on all aspects. This is an example of that. So what Azure has is another feature called versioning. So what versioning means is, if you upload a blob once, you have that blob, right? B1. Now let's say you want to change its data, so you override it with new data. So B1 data 1. Now you overwrite it with B1 data 2. Without versioning, this data will not exist anymore. Only this data will exist in the blob. However, with versioning enabled, the latest version has this data, but you can go and look at the previous version and this will have data 1. And actually you can do the same thing with the same data as well. So you can just create a new version with different data. And why this is relevant is because even though they have different data, Azure will actually um, price you for this data as well. They'll charge you for this data as well. So that's interesting, right? So that means it is even more important that idempotence is followed for this kind of data, right? For version data. So now what Azure has is, right? So they don't have any special accounting for this versioning and idempotence. So I mean, what I think what they do is, without versioning, they just override the blob. That makes sense. The operation is still idempotent. But with versioning, they override it, and because of this invariance of the system, it will create another version. Now, why that is a problem is because this is we are working on a distributed network. So I'll let you on a very good secret. All these distributed systems rely on one very simple trick: retry. So what if, say, I wanted to create a blob and then I retry it because I failed? You may say, well, if the first operation failed, then they wouldn't have created the blob, so it is still idempotent. But what if this is me, a stupid person, and this is Azure, supposed to be smart, and I say create blob 1 with data 1, and they create it, and then they send me the response, but due to network, this response never reaches me. I wait for a long enough time, and then I do a retry. It's an idempotent API. What can go wrong? Well, so they already had this blob, right? Why am I making it like a queue? So they had this blob 1 with data 1. Now, because I made the same call again, and they just create another version, they have created another version, and now they have charged me twice as much for storing the data. But I did the API call because I saw I never received a response. But they didn't really see that. I mean, they could have technically seen that I mean, that doesn't matter. But I never saw the response. Okay. So this API, is it idempotent? No, this is not idempotent, right? And this is the problem with this API. And due to this, where's my board? Okay. So due to this, what can happen is you may ask the Azure Blob Store to create one blob and versioning is enabled. But because you had network errors, so you retry thinking it should be idempotent. I mean, an API like this must be idempotent. I mean, it's a put API, it's an Azure Blob API. Why wouldn't it be idempotent? But it is not idempotent, and you end up with 2x the money being paid from your credit card that you are never gonna pay. You're just gonna beg Microsoft to waive that, right? Yeah, we all do that. So this is the problem. and that is why this is not idempotent. Uh, so now, and by the way, the way I found this problem was pretty interesting, so I'll just go there. So what we were seeing is, and this is actually a segment on why assertions are so good. So yeah, what was happening is we were in some workflow we were creating Azure blobs, and in some other workflow we were deleting them. And while deleting, we would assert that there should only be one version. I mean, we only created once, there should be only one, but we had an assert anyways. It like many people would look at it and think this is garbage code, but it wasn't, because that assert started to fail for some reason. And when I looked into it, I saw that the versions, the 2 or 3 versions that were there, were the first 2 versions were always 3 seconds apart, which exactly matched our retry policy, with the first retry being 3 seconds. And that just explained to me that, okay, this API is not idempotent. So now the question is, how do you make this idempotent at all, right? And well, there's a very simple solution. When you get a request, you also ask the client to have a request ID. Okay, request ID. And then for this request ID, you have done something, right? That is creating the blob. So, and you send the response, it never reached. So when the same request ID is reperformed, you see that, okay, I've already done the operation, so I can just return a response. And this time we get it. So there's only one version created, right? So that's how it generally happens. But wait, where will you store this request ID mapping to the operation you performed? Well, there's a few solutions. You can store it in memory, but then the more state you store in memory, the more scaling problems will occur, right? So you can store it in a database, but then that database will grow very, very large for no particular reason, right? You're just storing request ID and whether they were completed or not. So here you have to make a trade-off. You can store it in memory cache that has a time timeout, right? So after 5 seconds, or maybe let's say 5 minutes, you will remove this entry from cache. That means if I still keep retrying after 5 minutes the same API, right? For some reason I'm just not able to get the response. Then you will perform the operation again and you will create another version. This becomes version 1 and you create version 2. Is this still idempotent? Well, technically it's not, but in a scope it is, right? In a scope of 5 minutes it is, and really that's a good enough scope in my opinion. But if you want exactly completeness, then you will have to store the request ID. And yeah, so this is actually one of the very common patterns in idempotent API design, where you have a client-side identifier. You can also have a server-side identifier, but that's usually for debugging and stuff. Excuse me. So yeah, you have a request ID. Based on that, you have to make sure that you are deduping the operation. And yeah, that's honestly what I wanted to cover. And this is exactly what I suggested. So interestingly, they have a client request ID here. And I'm not stupid, so I did try this, but actually this is only used for analytics purposes. It is not used to make it idempotent. And in their defense, they never mentioned it as idempotent. But if you think from an API design perspective, it should be idempotent. And I mean, they agreed, I think. This is an issue with service backend. This is nothing can be done from SDK side. Obviously, I just wanted to get it to their attention. This is a rare case. Well, it's not rare at our scale. Um, and they even created a service backlog item to fix it. So because it is intuitively obvious that you should have this as idempotent API. So well, yeah, that was my small, not rant, not a dunk, not a hate video on Azure and Microsoft. I mean, I actually like Azure. Azure is really nice. They do a lot of good stuff. No hate, all fun and games. I'm kidding.